In order to find the exact value for something like sine 19 pi by 12, you might be asking yourself about the 12 in the denominator and how you're going to be able to handle that. Well, first let's look at some tools that we have to find exact values for angles. So as always, we can use our sine or cos curve when we're given 0, pi by 2, or pi, or 3 pi by 2 as our angles. We can find exact values for the ratios that go along with those. So for example, if I know my sine graph looks like this, and they ask me what sine of pi is, I can give an exact value for the ratio. I know it's 0. Same thing goes for cosine. If I asked what is cos of pi, you could go over to pi on your graph and look up the exact ratio value is -1. If you have denominators in your fractions like 4, 3, or 6, so pi by 4, pi by 3, pi by 6, and multiples of those fractions, then you are looking at your special triangles to find ratios. So for example, if you wanted to find cos 5 pi by 6, the first thing you would do is you would draw your angle in standard position. Five pi by 6 is in the second quadrant. So our angle in standard position is here, 5 pi by 6, and our related angle is pi by 6. Using our cast rule, we know that only sine is positive in the second quadrant. So if I am looking at cosine, I know cos 5 pi by 6 will be negative in the second quadrant. So it's going to be the same as negative cos pi by 6. I know it's sine. Then I just have to use the appropriate special triangle. So I need to figure out what is cos of pi by 6. Well, cos of pi by 6, I look at pi by 6 in my special triangle. I know that cosine is adjacent over hypotenuse, which equals √3 over 2. So cos of 5 pi by 6 is negative √3 over 2. So you just need to figure out the sine based on the cast rule and then use your appropriate special triangle. The next issue is breaking down something like 19 pi by 12 with those tools that we've looked at. So 19 pi by 12 can be broken down into friendlier parts where you're going to start to see some of those common fractions. So the pi by 2, pi, 3 pi by 2, pi over 6, pi over 4, pi over 3, or multiples of any of those showing up. So what we want to do, our goal is to figure out what are two angles that add to 19 pi by 12, or it could actually be the difference. Because we have these set of formulas that you will see on your formula sheet. So you should always have that out when you're working through these. There's 6 formulas. There's one for sine, cos, and tan, and there's sum and difference formulas. So we're going to start with the sine formula because we were asked about sine. And we're going to try with the sum formula to break down what are two angles that could add to 19 pi by 12. So we're going to start by saying, well, 19 pi by 12 could be 1 pi by 12 plus 18 pi by 12. This is good because 18 pi by 12 reduces to 3 pi by 2, which is one of those special denominators, but pi by 12 does not reduce further. Same thing with if I tried 2 pi by 12 and 17 pi by 12. That equals 19 pi by 12, but 17 pi by 12 does not reduce any further. Finally, I think we have some luck when we get to 3 pi by 12. If I add 3 pi by 12 and 16 pi by 12, I will end up with pi by 4 when I reduce 3 over 2, or 12 pi, and 16 pi by 12 reduces to 4 pi over 3, and both of those have those nice denominators that I was talking about. So I know that I can replace 19 pi by 12 with pi by 4 plus 4 pi by 3, and it's the same thing. So what I'm going to do now, this is my x and this is my y, and I'm going to grab that formula on the formula sheet, sine x plus y equals sine x cos y plus cos x sine y, and I'm going to just simply put in, for x and y, the angles that I just found. Then I'm going to start to fill those in. Sine pi by 4, if I look at my special triangles, this is a first quadrant angle. We don't need to worry. We know that in the first quadrant, all ratios are positive. So pi by 4, cos or sine will both be positive. And just looking at my special triangle, pi by 4, if I'm interested in sine, opposite over hypotenuse is 1 over root 2. So I replace all of this with 1 over root 2. Cos 4 pi by 3, we'll come back to in a moment. Cos pi by 4 adjacent over hypotenuse is also 1 over root 2. And sine 4 pi by 3 we'll come back to. So if I was to draw an angle in standard position, 4 pi by 3 ends up in the third quadrant here. And using the cast rule, remember that's the tan quadrant. So this is 4 pi by 3, and my related angle with the x-axis is pi by 3. So what I know then is that in that quadrant, tan is positive, cos is negative, and so is sine. So those are both going to be negative numbers that I'm multiplying by. And if I look up the cos ratio for pi by 3 for my special triangle, cos is adjacent over hypotenuse, so it's going to be a half. So cos 4 pi by 3 is the same as negative cos pi by 3, so it's going to be negative a half. Sine of 4 pi by 3, well, sine is opposite over hypotenuse, so it's going to be root 3 over 2, and again it's negative because it's in that third quadrant. Now when I multiply out, I end up with negative 1 over 2 root 2 minus root 3 over 2 root 2, or as a single exact value, minus negative 1 minus root 3 over 2 root 2. So this is an exact value, and I could find it even though I didn't know much about pi by 12. I could use what I knew about special triangles and the cast rule and my new sum formula, compound angle formula, to help me. And I can leave it there for the final answer.